We're going to start example number 2 on dimensionless analysis. So for this particular example, let's consider a very practical example. Let's say you have a tip deflection of a cantilever beam, and we know that the cantilever beam is a function of W, L, I, and E. The way this works is that couple of ways we could address this issue. One way we could do is that we know that your delta is a function of weight, is a function of length, is a function of Young's modulus, is a function of inertia. And what we know in the problem is we know uh, from that this is mass times length over time squared. We know that the length well is length. We know this is uh, force over length squared, but we know that force is mass length t squared times 1 over L squared. So that would be mass times length over t squared, over L. We know this is L to the 4th power, okay? And we know that this is to the L. So what's going to happen is on this side, we know this is L and L to the 1, but it will be the same as adding m sub 0 and t to the 0, right? But anything to the 0th power is 1, anything to the 0th power is 1, and I have 1 L, so just put 1. And on this side, what we will do is we can go ahead and say, add some letters, L to the B, E to the C, I to the D. And we're going to take our dimensional analysis and put it there. Mass, length times squared times A. We know L is L to the B. E is mass times squared times L to the C, and we know this is L to the 4 times D. Okay, so we know this. Now, what you have to do is we need to expand all this so we can compare the variables on one side and the other side. So let's copy this so we can have it handy on the next page. So we have M0, T0, L1, and we're going to have M will be A plus C. You can see have an M here, M there. And then time will be minus 2A minus 2C. I got a time squared and time squared to the C. That's where that comes from. And then I'm going to have L from here to the A, L and B plus B, L minus C, and to the 4th plus 4D. Okay, so now we start comparing on both sides. A plus C is equal to 0. This comes from M. For time, we get minus 2A minus 2C is equal to 0. From these two equations, we basically get the same answer. So C is equal to minus A. The last one from L, we find this is A minus C plus B plus 4D is equal to 0. And we can solve for any variable. I chose to solve this for B. B is equal to minus 4D plus C and and this minus A. Okay. we know from here, this is minus A. This is minus A. So this thing becomes minus 4D minus 2A. So now we will take this and plug it back inside here and see what we have. Okay, so let's go to the next page. Now we have delta is equal to WA. We have LB. We have EC, ID. So let's replace. We're going to keep the A and D's intact. So B was equal to minus 4 minus 2A minus 4D minus 2A, and C was equal to minus A. I is equal to D. Okay, so now we're going to rearrange everything with the same exponent. So this becomes WA 1 divided by L over 2A, 1 divided by EA, and then we have ID, and then divided by 4LD. So now we can combine everything and say L. They have please fix this. This is not 0. This is equal to 1. So there's a plus 1. There's a plus 1 here. This is because L is equal to 1. You see it here? It's not equal to 0. It's equal to 1. So then this is plus 1. And then I have L to the 1. Okay, floating around. So now we combine the terms and we have W EL squared to the A, I L to the 4th to the D, and we have an L. We could take this, we could take this L and bring it on this side as well, or bring delta on this side, and we could further say delta over L is going to be a function of I to the 4th comma W E L squared. Okay, this will be pi 1, this will be pi 2. And then if you just compare this with the answers that we know for mechanics of material, let's take this and copy this in the next page. Okay, so if we compare this with mechanics of material, we know for mechanics of material that delta is equal to 1/3 W L cubed EI. So this comes from mechanics of material, so we know that. And we can probably go ahead and rearrange this a little bit. And we can see that this becomes 1/3 W. And what we could do is we could leave E and L squared. Just let me go back for a step. So what I want to do is I need L squared here, so multiply by a 1, right? I can do that. L squared divided by L squared. So now I have an L squared at the bottom. And then I have L to the third times I. Um, so now we can further combine the terms. 1/3 W EL squared times, keep one L there, L to the fourth EI times L. And then from these two, if I compare these two equations, we can show that what you have is delta L, okay? You have a constant 1/3. This term remains as is, WEL squared. And then this term remains, this is how we defined it. So we want to keep it like that, L to the fourth. And it will be -1 when I compare to this one. And the L actually came to the other side. So this is how these two get related one another. This is a very good example where we went to a real world problem and we were able to show the dimensional analysis and figure out what equations will actually look like at the end of the day. Now, this is a -1 there, but the -1 actually comes by comparing this with the physical problem. But you want to rewrite this in terms of pi1 and pi2. This is not a comma, by the way. This is actually pi1. Okay, these are my non-dimensional parameters. Another way to do this problem would have been also maybe keeping W outside and solving everything there. Or we could have even kept this inside here. So another alternative would have been, what if I wanted to solve everything like this? This is also possible. Maybe I wanted to have an expression that looks something like this. This could be possible. The only difference I will have to do in this particular case, this is like another problem. Okay, so in this particular case, this whole thing is a pi. This is completely non-dimensional. So in this case, we say all the dimensions on this side, L, T, M, everything will be to the 0th power. And then on this side, I can just say, let's use the same approach that we used before. So we had WA, LB, EC, ID, and now we have a delta E. Okay, so you basically, now what you're doing in the problem is you just have one extra variable, and what you can see is I got three three-dimensional quantities, right? I have 1, 2, 3, 4, 5 here, 5 elements. So what that is telling you, so what this is really telling you is, at the end of the day, you will get, and you're able to do only 2 expressions, and you will be able to show that you're going to get only 2 equations. So if I got 5 here, and I can do only 2 equations, I can only get 2 equations, then that would give me 3 minus 2 will give me 3. That means that I'm going to have 3 different expressions and one of the expressions will be delta over L. So this is, we will leave this for your homework, so you can kind of work it out and you can learn how this is done. But this is kind of the idea on how these problems actually work. The problems are not very complicated. You just have to be systematic to make sure that your left-hand side and your right-hand side in dimensions are equal. And then you get your answers. That's what you're looking for. At the end of the day, what you're looking for is you're looking for your pi 1, pi 2. Or maybe this is completely non-dimensional, then the problem looks like this. And you just end up finding what these coefficients are. So this concludes example number 2.